All right, now that we've got a handle on following our arrows, looking at common motifs, we can start combining these motifs together. So organic chemistry is one big puzzle. You can think of it kind of maybe as like a game of chess or something like that. And so with any game, the more you play, the better you get. So the key thing really here is doing practice problem after practice problem after practice problem. And so let's go ahead and take a look at a reaction here. And so here we have an overall reaction that's made out of quite a few different steps. And so for now, what you want to do is pause the video and identify what the differences are between the left and the right side. All right, so once we identify the differences, we can then think of a plan. So let's go ahead and first take a look at the differences. So first off, we see this OH here. We see no OH over here. And so that must mean that it's gone. It must have gotten eliminated. It's missing, right? Something happened to it. Next up, we see a bromine as a reactant. And then we see the Br in our product. And so that means that this Br must have been added into here. And then finally, there's one thing that you may not have noticed, right? There's this carbon over here has 3 methyl groups, whereas in the products, it only has 2 methyl groups. And this carbon over here has 1 methyl group, where in the products, it has 2 methyl groups. So this methyl group went from over here on the right side to over on the left side. So it must have gotten rearranged. And so we can start piecing these things together. So I'll give you most of the data here, and then you guys will be able to kind of fill in the blanks. So the first step of this reaction is we're going to take our alcohol, combine it with HBr. To get this product right here. And so here we have an OH, here we have a water, right? So we're thinking, and then here we have an acid, hydrobromic acid, and so we're thinking acid-base reaction. And so we can have a lone pair attack this hydrogen, break this bond, and then we'll get our product in the end. And then one thing you may notice is that this is water, right? So water is a very good leaving group. So for our next step, we're going to go from the product on the left to the product on the right. And again, what you should identify is water is a good leaving group, so it is going to leave. It's got that positive charge. And once it leaves, we'll be left with this positive charge right here. So this is an example of a leaving group leaving. So we'll just call that Lg. Got this methyl group and all of these components, my bad. All right, so in the next step of the reaction, we have this occur, right? So we can see that our positive charge has now moved, and so has a methyl group. And so what we're thinking about here is an alkyl shift, right? So we can move this CH3 over here. So this is an example of a rearrangement. And if you think about it, it does make sense, right? This carbocation over here is a secondary carbocation, whereas over on the right, it is a tertiary carbocation. And then in our last step here, we finally get our product. And so we can think about how do we go from the left to the right? Well, we see a positive electrophilic spot. We see a negatively charged nucleophile. And so we can have a nucleophilic attack. Occur here. And then finally, that'll give us our final product. And so you can see this mechanism is a combination of many of the different motifs that we've gone ahead and put together. Sometimes these reactions happen in one step. And so we can think about what's going to happen over here. Remember that this sodium is just a spectator ion. So really what we're thinking about here is hydroxide. Over here, we have this bromine. On the right, we have a bromide. And so we're thinking maybe a leaving group leaving, something like that. And then, of course, we're attaching the alcohol over here. So we're thinking a nucleophilic attack. And so we can draw a mechanism that looks like that. If you think about doing this in 2 steps, right, maybe you're thinking, oh, okay, maybe first the bromide leaves. And then we're left with a carbocation. That's not going to be a very good idea because this is a primary carbocation, which is not very stable. And so that's a subtle difference. We'll delve into these kind of differences deeper or later on. And so again, here's another example. Think about what's on the left, what's on the right. First thing you want to probably notice is that this is a hydroxide. So we're thinking something like that. We see that we have no bromine over here. So that means that bromine must have left. Right? And then if you think about what other bonds are over here, there's a hydrogen over here, whereas this carbon has 2 hydrogens. So we have to get rid of one of these hydrogens. We have a base. So maybe you're thinking this hydrogen can be picked up by this base. And then, of course, we have to break this bond. And if we're thinking about where this bond is going to go, over here, we've got a single bond. Over here, we've got a double bond. And so we can move the electrons from this single bond to this double bond to form our alkene in the end, right? So overall, this isn't easy. And we're going to spend a lot of time looking at these details. This section is really just to get you a little bit of a primer, to get you to start seeing some of these things, to get you to start noticing some motifs, to get you to be able to follow some of these arrows, to recognize some of these motifs. And then later on, we'll get into the deeper, more complicated stuffs and be able to figure out, go from the start to the end without any help. But for now, you'll receive a lot of help through these steps.